This presentation on cellular evolution from the advanced mobile phone system to 5G was done by Team 9, which consists of Norma Granados, Brian Lopez, and Tommy Garcia.
After the first mobile phone system was introduced back in 1983, people have constantly been asking for more speed, more data, more coverage. Due to this, cellular technology has continued to advance in an unprecedented manner over the past decades. It has reached a point where you can instantly communicate with people on the other side of the world.
1G, also known as the Advanced Mobile Phone System, is used for voice services and was introduced in America in the 1980s. It has frequency modulation with a channel capacity of 30 kHz, with frequency division multiple axis. The frequency band is of 824 to 894 MHz, and the features include analog signal, a speed of 2 kilobytes per second, and voice calls in one country. The disadvantages of 1G include poor voice quality, poor battery life, large phone size, limited capacity, poor security, poor handoff reliability, and low spectrum of efficiency. It introduces mobile telephone system, advanced mobile telephone system, improves mobile telephone service, and push to talk. Due to the disadvantages listed above, AMPS was very vulnerable to an eavesdropper. This led to a banning of scanners and made it illegal to intercept calls. 2G, also known as a Global Systems for Mobile Communication, was introduced in 1990. It has Gaussian minimum shift keying modulation at a 200 kHz channel. The features include digital signal with a speed of 64 kilobytes per second, better quality and capacity, and also enables text messages, picture messages, and multimedia messages. The disadvantages are that it cannot handle videos, as well as requiring strong digital signals to help mobile phones work. If there is no network coverage in any specific area, digital signals will weaken. 2.5G has a feature a little bit different. Starting with a speed of 64 to 144 kilobytes per second, phone calls, send and receiving emails, web browsing, and camera phones. 2.75G has reduced transmission time interval as well as downlink dual carrier.
3G was implemented by using two technologies that were deployed at around the same time. These two technologies were the Universal Mobile Telecommunication System that was deployed in Europe by the year 2000 and Code Division Multiple Access 2000, which is the American version of UMTS and was deployed in the year 2002. These two technologies had downlink speeds of up to 2.4 megabits per second and uplink speeds of up to 153 kilobits per second. They also had a data rate of 384 kilobits per second. 3G offered key features that included higher data rates, video calling, more security than 2G, more users were able to be supported over a 3G network, more coverage, multimedia message support, location tracking and GPS, better web browsing, and TV streaming. Over time, 3G systems had to be updated in order to increase the data rate due to higher demand. Two technologies were introduced in order to achieve this. They were called the high-speed downlink packet access and the high-speed uplink packet access. Due to this improvement, the downlink speeds went from 7.2 megabits per second all the way to 42 megabits per second, and the uplink speeds went from 384 kilobits per second all the way up to 11.5 megabits per second, a significant improvement over the previous speeds. Some of the disadvantages of 3G systems was that the licenses required to offer 3G services to the public were very expensive, as was the implementation of the infrastructure for these networks. Due to the demand for higher network speeds and higher data rates, it required much higher bandwidth, and because of all these improvements, mobile phones became more expensive. Due to all of this, compatibility with older 2G systems suffered. What we have today is what we call 4G networks. Communication between devices in these networks is mostly done through the Internet Protocol. 4G networks also offer theoretical speeds from 10 megabits per second up to 1 gigabits per second, although it is rare for speeds to reach that high. The bandwidth required to operate 4G networks is 200 megabits per second. All the communication is done through packet switching in order to guarantee better connectivity and less calls dropped. Some of the key features offered by 4G networks include higher security, improved call quality, reduced latency, high-definition streaming and gaming, and voice over LTE networks. Some of the main disadvantages of 4G networks include that the battery life of phones do not last as long because they have to support this new technology. Hardware and infrastructure is also more expensive, much like 3G networks were. And mobile devices also became more expensive due to the technology that was crammed inside them to make them compatible with 4G networks. It is also very time-consuming to deploy and upgrade 4G networks over large areas.
5G. The first phase is completed in March 2019. The second phase is said to be completed in March 2020. The theoretical speeds of 5G is up to 20 gigabits per second, specified by ITU's IMT 2020 standard. IMT, the 2020 standard, will use frequencies of 24 gigahertz to 86 gigahertz. 3GPP, 5G NR standard, will use frequencies of 3.3 gigahertz to 5 gigahertz at the beginning. ITU has divided 5G services in three categories. 1. EMBB for mobile phones. 2. URLLC for industrial applications and autonomous vehicles. And 3. for MMTC for sensors. Some of the deployment areas for 5G include Australia, Bangladesh, Finland and Estonia, Indonesia, Latvia, Lesotho, Norway, Philippines, Qatar, South Korea, Spain, United Kingdoms, and United States. The theoretical capabilities of 5G in these deployment areas are expected to have a peak data rate of 20 gigabits per second. User experience data rate should be 1 gigabit per second. The latency should be around 1 millisecond. And the connection density should be 10 to the 6 over kilometers squared. The energy efficiency is the same as 4G, which is ideal because we don't want to be using more energy for more power. The area traffic capacity is 1,000 megabits per second over a meter squared.
To recap, 1G was used for voice calls, 2G introduced SMS messaging and emails, 3G introduced the internet, applications, and videos. 4G networks were able to support many more devices and much faster speeds than 3G networks. 5G networks will be able to offer substantially faster speeds, less latency, and always-on connectivity.
These are our references, and thank you for listening to our presentation.